Title of the first section of notes today is Adding Radicals. First problem is 2 radical 5 plus 4 radical 5. When adding radicals, the radical number underneath the square root must be exactly the same. As long as they're the same, we can add the coefficients. 2 plus 4 would be 6, and the radical 5s would stay the same, so our answer would be 6 radical 5. Second question, and last question for the section. Radical 18 plus radical 2. This time the numbers underneath the square root or radical are different, so what we have to do is change one or both of them. In this case, the 18 we can do a factor tree for. Two numbers that multiply get 18. Could use 9 and 2. The 9 we can factor to 3 and 3. Circling our pairs, we have a pair of 3's. That number would go outside the radical, and we have a single 2 that stays inside the radical. Bringing down the plus radical 2. Our new problem would be 3 radical 2 plus radical 2. There's no number in front of the radical. We can put a 1 for the coefficient. Both radicals are exactly the same, so we can add the coefficients 3 plus 1, and the radical 2's would stay the same. So our final answer, 18 radical 18 plus radical 2 would be 4 radical 2. Next section of notes is titled Subtracting Radicals. First problem is 6 radical 7 minus 4 radical 7. Just like when adding radicals, when we subtract, the number underneath the square root or radical must be exactly the same, and then we can subtract the coefficients. In this case, it would be 6 minus 4, which would be 2, and the radical 7 would remain the same. So our final answer would be 2 radical 7. Second question is 2 radical 12 minus 7 radical 3. Again, before we subtract radicals, the radical number must be exactly the same. In this case, we have a 12 and a 3. So you want to factor whichever one we can. The 12, for example, we can factor that to 4 times 3, and the 4 we can factor to 2 times 2. So radical 12, we'd have a pair of 2's, and the 3 left over would go on the inside. It would be 2 radical 3. The question is 2 radical 12, so this extra 2 would come down, and we can multiply by the pair of 2's that we had, so this would be 4 radical 3. And we're subtracting 7 radical 3. Again, once the radicals are exactly the same, you can subtract the coefficients. 4 minus 7 would be negative 3, and the radical 3's would stay the same. So our final answer would be negative 3 radical 3. And last question for the section is negative 5 radical 3 minus 3 radical 3. Again, the radicals in this case are exactly the same, radical 3. So we can subtract the coefficients, which would be negative 5 minus 3. Same signs, we would add those, it becomes negative 8, and the radical 3 would stay the same. So our final answer would be negative 8 radical 3. Last section of notes today is titled Multiplying. Radicals. First problem is radical 2, and the quantity, or inside parentheses, is radical 8 minus 4. When multiplying a radical times a parentheses, the same property that we've done before, we can use distributive property. Multiplying radical 2 times radical 8, since they're both underneath a square root or a radical, we can multiply 2 times 8, which would be 16, and leave that number underneath a radical. And then minus. Multiplying a radical 2 times a number that's not inside the radical, that number 4 would go outside the radical, and the 2 would stay inside the radical. So radical 2 times negative 4 would be negative or minus 4 radical 2. Simplifying this problem, radical 16 or square root 16 would be equal to 4, and radical 2 cannot be simplified. So our final answer would be 4 minus 4 radical 2. The 4's you cannot subtract. One has a radical after it, and one is just a number. In order to subtract them, they both have to have the same radical. Second question is 2 radical 3 multiplied by the quantity, or inside parentheses, radical 3 minus 1. Again, just like before, we will distribute the 2 radical 3 to both the numbers on the inside. 2 radical 3 times radical 3. The 2 would stay the same because it's outside the radical or square root sign. And radical 3 times radical 3, 3 times 3 would be 9, and that would go underneath the radical. And then minus 2 radical 3 times a negative 1 would stay the same, but it would be minus 2 radical 3. Multiplying the negative 1 times 2 gets you the negative 2. Check to see if you can simplify. Radical 9 or square root 9 is equal to 3. And we can multiply 2 times 3, which would be 6. So our final answer would be 6 minus 2 radical 3. And again, these 6 minus 2, you can't subtract those because one has a radical and one does not. Last question for this section. First parentheses is 3 radical 2 plus radical 3. And in the second parentheses, radical 2 minus 5 radical 3. This time we have 2 parentheses. Both of them have 2 terms or 2 radicals. In this case, we'll be multiplying by FOIL. We'll multiply the first terms together, which would be 3 radical 2 times radical 2. The 3 would stay the same, and radical 2 times radical 2 would be radical 4. Multiplying the outside terms for FOIL would be 3 radical 2 times negative 5 radical 3. The numbers outside the radical, 3 and negative 5, we can multiply for negative 15, and radical 2 times radical 3 would be radical 6. Multiplying the inside term, radical 3 times radical 2. That would be positive radical 6. And multiplying the last terms, radical 3 times negative 5 radical 3. Negative 5 would stay the same. And radical 3 times radical 3 would be radical 9. Simplifying, radical 4 or square root of 4 would be 2. These middle terms have the same radical or same square root. We have negative 15 radical 6 plus 1 more radical 6. We can put a 1 as the coefficient. Negative 15 plus 1 would be negative 14. And radical 6 would stay the same. And the last term, negative 5 radical 9. The radical 9 or square root 9 would be 3. So we can change that to multiplying by 3. 3 times 2 would be 6. Minus 14 radical 6. And negative 5 times 3 would be negative 15. Last step, combining like terms. We have a 6 and a minus 15. Both are just integers without radicals. So 6 minus 15 would be negative 9. And minus 14 radical 6 would stay the same. So our final answer, negative 9 minus 14 radical 6. And again, the negative 9 and negative 14, we can't subtract those because the 14 has a radical and the 9 does not.